Hey everyone, welcome to my channel. Here we are going to break down a pretty much intuitive problem called number of islands. I think this is a great problem for practicing BFS and just overall work with matrices. So basically we have a grid that consists of ones and zeros. One represents a land and zero represents a water, and we need to find the number of islands. And what is island? Island is a group of ones. As you can see here, these are all one island. So island is a group of ones or squares with land that are connected either horizontally or vertically. And yeah, this is a really good problem. Let's see what we can do for it. Okay, so here I have our test case 1. As I said, it is a pretty much intuitive problem. To solve it, we need to know BFS algorithm. Unfortunately, I will not explain what BFS is, but I will leave a link in the description for an article that explains how does BFS work, and also a couple of practice problems that should help you understand how does BFS work. Yeah, so anyways, here's my idea for that problem. Obviously, just counting the number of ones is not gonna work, because if, let's say, this and this, they're both part of one island. If we just count them two, they will have 2 islands for our answer and not one, which is bad. So that's why my idea is, whenever we find a new unvisited land, we'll go through all of the ones that are connected to it and mark them as visited. So let's say we start from this one, and we're gonna see if we can move from this square to another square, which is also a land, and we also haven't visited this square. So yeah, so for this we will see we will have this and then we're gonna add them to our list of squares that we want to check, and then for them we're gonna add lands that are connected to them. So for this it will be this and this, and for this square we will not add this because it will be visited from here, right? So we'll only add this. Yeah, and that's how we will visit all of the squares for this island. And then once we see that we can't go anywhere, so let's say for this one, as we can see, we have a land here, but it is already visited, so we will not move there, and we have zeros surrounding it, so we can't go anywhere, and our BFS will stop. So yeah, so basically once we finished, we'll just add 1 to our answer, which is the number of islands. So once we've finished, we're gonna after this island we don't have any more islands, so we just will print 1, right? And so here's our test case 2. Yeah, so basically we'll start from this one, and as we can see we can move here, right, and move here. Yeah, so after that we choose any of them, let's say this, and we can see that from here we can move here, and from here we can see it is connected to this, but because we have already visited it, we will not add this to our queue, to our queue of squares. And then from here we can go here because they are not connected. neither horizontally or vertically. So yeah, this will be one island, right? And then let's say for this, we only have this one, right? So it will be second island. And then this is our third island. We're gonna start from this one. You can see it is only connected to this, right? So it will be, it will go here, and then from here it can go anywhere. So this will be 3. That's our answer. 3. Alright. Sounds easy, right? Let's implement this. Okay, so here I have my code. We're gonna need to first find sizes of our metric. Yeah, so this is the size of our grid. And then let's create a matrix that will help us mark our squares on the grid as visited or not. So it will be visited. So the reason why I wrote 300 is because our grid size can be greater than that according to problem statement. So yeah, for some reason Leetcode will not let me write M here, but it is easily fixable if we just write 300 by 300. Yep. So next we'll need a queue for our BFS. I'm making it paired because we're saving i's and j's for each square. Okay. So these two force are to make zeros in all of the squares for our visited, because at the start we haven't visited any of the squares. So yeah, it will be, yeah. And then we need to count our answer. So let's make this variable to count our answer, and then let's start our solution. So here I'm going through the entire matrix. Okay, so here we are checking if it is a land and we haven't visited it yet. So yeah, see, if this is 1, then that means that we are in the land. Sorry, my bad. If we haven't visited it yet, then it will be 0. So we are checking if visited or the square is 0. That means that we haven't visited yet. That's pretty simple. And then here we're gonna mark this square as visited. Then we're gonna push it into our queue by saving its indexes. And then yeah, let's make our answer +1. We can make this after BFS or before, it doesn't matter, it will work anyway. Yeah, and here we're gonna start our BFS. So while queue is not empty, because once queue is empty, that means that we can go anywhere, so we just stop. Okay, so these are indexes of the square that we'll be working with, and let's like this so that um we q dash q point pop deletes it from the queue, and that means that we will not work with this square after that. So yeah. Okay, so here I'm checking the upper square. This is to make sure that x minus 1 will not go out of our grid. Yeah, so this is, let's the square. Then we're gonna check the mobile one. So maybe this. So this is our lower square. And then we need to check left and right. So it'll be if y is not equal to 0 and right first. Um, that's right. This is left square. And now the last one is the right square. Yeah, so basically that's it for our BFS. Yeah, so all these comparisons were to make sure that we are not going out of our grid, and this visited, we just check if we haven't visited our square, and here we're checking if it is a land, another one. So after that, I guess we just need to print our solution. Yeah, so this is our answer. Yeah, I guess that's all. This should work. Let's run it. Let's see if it works. It does not. But let's say here. Okay, let's say here. Yeah, I think it was because of this. Yeah, it was because of this small mistake. Okay. So let's submit it and check if it works. Hopefully it does. What's that? Right. And so just found the mistake. It was here. Should be great like that because well, this is the um this is going to be the length and this is going to be the width of our grid. So yeah, now this should work, I guess. And yeah, it worked. Our run time is 24 milliseconds. Yeah. Let's see. Yeah, and there was a pretty quick guide for that problem. Thank you guys for watching. Make sure to like and subscribe. See you all in the next one.